All right, working on here lesson 8.2. We're talking about ratios of similar polygons. And here's the cool thing. We know ratios are just fractions that compare. And I easily can do that with this, but I want to understand what similarity is. Remember, similarity, things that are the same shape, but they are different sizes. And we showed on the board in class, like, it's very easy to look at congruency and see everything matches. Like, I know this side goes with this side, this angle goes with this angle, the hypotenuse goes with the hypotenuse. It's very similar. Well, similar polygons are the same way. What if I make the same idea, but I go ahead and I have it just a little bit larger? Well, the angles are still the same. They're both 45 degrees, right? It's just that it's a different size, but the shape is exactly the same shape. It's still an isosceles right triangle. So when we have things that are exactly the same shape but different sizes in this sense, we call them similar. Now, similar, notice the symbol is just that little tilde symbol. That means they have the same shape but not necessarily the same size. So here's an example. Two isosceles triangles, those are similar because they're exactly the same shape but different sizes. 1 and 2 are both same types of, let's say they're both triangles but not the same type of triangles. So they're not similar to each other. So we have to fill in our definitions here. So with this one, two polygons are similar if and only if their corresponding angles are congruent, matchy-matchy, just like congruency, I match them up, and their corresponding side lengths are proportional. So notice here's these two trapezoids. ABCD is similar to EFGH. Angle A goes with angle E. Angle C, for instance, goes with angle G. I matchy-matchy like we do first semester. And notice, here's your corresponding angles. Now notice they say the corresponding side lengths are proportional. That means all have the same ratio. That means all the corresponding sides had to have the same ratio. And they show you here, notice all of the ones from the same polygon are on top, all of the corresponding ones from the other polygon are on the bottom. They all come down to 1/2. Well, that ratio has a name. That's called the similarity ratio. Now, similarity ratio just says, how does it work? We used to call this, like on a map, you'd call that the scale. On maps, called the scale. So, I mean, that really doesn't change. So when I say similarity ratio, that's what I'm doing. What's the scale between the two figures? SR is the abbreviation for similarity ratio. Now, that's my abbreviation. I don't think the book has one, but I use it. When you name similarity ratio, you need to know which polygon you're starting with, which one you're ending with. So when I have these two equilateral triangles down below, if I said I want the similarity ratio of triangle ABC to triangle DEF, the triangle that's named first, its side has to be the one in the numerator. The one that's named second, it's in the denominator. So notice I get 3 to 6. I'd go AB to ED, let's just say for instance. AB to, DE. So 3 to 6, my similar ratio is 1/2. But notice, what if I named it differently? What if I said triangle DEF to ABC? Then I'm going from the larger one to the smaller one, so it ends up being 2 to 1. Or you can say 6 is to 3, it's 2 to 1. So it just switches directions. So when you have similarity ratio, it tells you how things are setting up. Now, for time-wise, I'm just going to flip the pages over, and I want to make sure that we understand the concept behind this. So let's do this first one, just identifying the pairs of congruent angles and corresponding sides. Now, we know if these are similar, and they say they're similar here, it's implied, okay, that everything has to match. So let's do angles first. Angle M goes with what angle? That's right, angle T. Angle N goes with what angle? Angle Q. Okay, we know angle P is congruent to what angle? Angle R. It's corresponding. Okay, it's all the same. Now when I do corresponding sides, I think ratios. So I go, well, I'm going from left to right. And by the way, if I don't tell you which way to go left to right. When you name similarity ratios and things, just go left to right. So when I do this, I get MN goes to which one? MN goes to TQ. Matchy, matchy. 2 to 1. Notice the next one. I'm going to go NP. I keep them all going the same way. I'm starting with the one on the left, they stay on top. NP goes with QR. Okay, 2 to 1. Then I have over here, MP is going to go with TR. And notice that ends up being, sorry, I'm very tired right here. MP is 2.2 over 1.1. That's 2 to 1. So they all have the same similarity ratio. All right, now in the next problem here, actually I think we're going to stop here and I'm going to start the next video after this.